From the previous slides, we have learned that every object, no matter it is cold or hot, will radiate infrared radiations. But in this slide, I want to let you know that every object, we know they will emit radiation. We will call it as the name called radiator. At the same time, that object will also be the absorber to receive the energy from other objects. So we can say an object will absorb radiations from the surrounding. At the same time, it will also emit. Emits means gives out or radiates. Radiations to the surroundings. So consider a cup of icy water. If you see the melting ice floating above the water surface, we know that the surface of the water has the temperatures of 0 degrees Celsius, while it is in the room temperature with 25 degrees Celsius. As we all know, every object will emit radiations to outside. At the same time, it will receive or absorb radiations from outside, right? So as a result, there are two processes happening in the icy water in the opposite direction. However, we know that if the object is cooler than surrounding, the rate of emissions of radiations will be slower than the absorptions of the radiation rate. As a result, here comes to the concepts of net that we have learned that in Form 2, Chapter 7, photosynthesis. When there are two processes occurring in opposite directions, we need to find out the net results. The net result now is it will gain the energy, gain the radiations, so as to increase its temperatures. However, if the situation is changed, now here is a cup of hot water replacing a cup of icy water. Obviously, the temperatures of the water is much higher than the surroundings. So, we know that now the rate of the emissions of the radiations will be greater than the rate of the absorptions of the radiations. Finally, there is a net radiations towards the surroundings, and hence the temperatures for the hot water will drop. Then you may ask, what if the water has the same temperatures with the surroundings? Will there be no more process of radiations transfer? The answer is no. Both emissions of the radiations and both absorptions of the radiation are now taking place. But if they have the same temperatures, the rate of these energy transfers are equal, so that there is no net energy transfer. I would say that the net energy transfer is 0 in this case. So as a result, the temperatures of the water remains the same. Here we are going to talk about another factor that will also affect the emissions and absorptions of radiations. It is color. From the experiment 4C, that I expect you to watch it after this photo slideshow. From the results of the video, I hope you can learn that dual black surfaces are good absorbers and also a good radiators of the radiations, while shiny and light color surface like a white color t-shirt or pale yellow color surfaces are poor absorber. At the same time, they are poor radiators of the radiations. That's why when we wear dark color t-shirts or dark color clothes, we will feel hotter than the others who wear white color t-shirts. The reason is under strong sunlight or in daytime, the dark color surfaces will allow a larger or net absorptions of the radiations than the people who wear the white color t-shirts. At the same time, at the cold night, the temperatures of the body or the t-shirt is now higher than the surroundings. As we all know that black surface not only a good absorber, at the same time it is also a good radiator. So it will also has a higher radiation emission rate than white color surface, that we will feel cooler. You can imagine if an astronaut wear the dew black or dark color spacesuits. In the daytime, it will absorb more energy, more radiations from the sun. And at night, it will also release more radiations to the surroundings. As a result, there will be a great change of the temperatures for the body temperatures, and it may threaten their lives. Here comes to the examples of different other examples of different how colors affect the emissions or absorption rate of the radiations. There are radiators installed at the front part of a car. It is painted black. The reason is we know that when the engine is running, the temperatures of the car is much higher than the surroundings. So we aims to release the energy away from the car as fast as it can. So black color really helps it, because as we know, the black color surfaces are good absorbers, and at the same time it is a good radiators, so energy can lose away very quickly. When we talk about in other pictures, the storage tank, it is painted silvery or white. The reason is we don't want to have a great change of temperatures inside the tent, because we know if the temperature is too high, the fuel may get burnt and it may cause fires. So we want to maintain the temperatures uniformly. As white color or paint color will absorb less and at the same time radiate less radiations. Some of them even will reflect the energy away. Okay. As a result, the fuel tank will not overheat. In the example below, example 5. That's why we know why the houses in Greece are painted white. The reason is white color surfaces are generally poor absorbers and poor radiators. Some of them may even reflect the energy away from it. That keeps the house cool. After discussing first two factors, temperature difference between the objects and the surroundings, and the colors of the objects. In addition to them, the emissions and the absorptions of the radiations by an object are also affected by its surface area. The larger the surface area will cause the higher rate of the radiations, emissions, or radiation absorption. In the table below, it summarizes all the factors and the corresponding effects of the emissions and absorptions of the radiations.